Greetings to all. The session is regarding intermediate chemistry. So the content what we are going to discuss here will be very much helpful for your international entrance examination, competitive exams as well. India is going to conduct JEE Advanced, JEE Mains examination for engineering stream, that is for IIT and NIT entrance exam twice a year, and NEET chemistry will be there, that is for medical entrance examination across India. Telangana and Andhra Pradesh government are conducting MCET examination, that is for BTech entrance. In addition, government organization is conducting examination for the career opportunities called government jobs, where general studies common question paper will be assigned. In that, general science content will be there. The session what we are discussing is very much helpful. Earlier, a series of classes were taken where we gone with the question to answer type of description. In this class, we are going to try to give the complete description about the content. Later on, previous year questions also mentioned what will be the examination pattern, what will be the question possibility from this topic to be mentioned over there. Let's enter into our today's session. Here it is the kind of content which is very much helpful for these many paradigms. So we collected the content from the International Union for Pure and Applied Chemistry, Cambridge Assessment International Education, National Testing Agency questions will be taken, Telangana and Andhra Pradesh MCETs questions will be taken, government jobs which are conducted by India level, that will be taken, Andhra Pradesh Public Service Commission, Telangana State Public Service Commission is also taken into the consideration. Let's see about the content for the day. We are going to discuss about the topic is called inductive effect. Today's topic is about inductive effect. Okay, so if the topic is inductive effect, what I'm going to discuss now, what we are going to discuss for the session, shall I know about what is meant by inductive effect and what is the consequence of inductive effect on the chemical reactivity of the substance and what significance it contains? Then, can I get any previous year questions from this inductive effect content? These many questions got poised, so that I would like to answer for all these whatever mentioned over here. Let's go with the solution for the questions based on inductive effect concept. Okay, for that purpose, first of all, we have to know what is meant by inductive effect. Let's see the definition. Inductive effect is always said to be a permanent effect which will not be diminished, and polarization or else displacement of electron density due to electron releasing or else electron withdrawing nature of the functional groups. Okay, so here already we know covalent bond is made up of two electrons, but these two electrons either migrated towards carbon atom or else the bond will be displaced towards the functional group. That depends upon this displacement or else polarization, the mobility of the bond either towards carbon or else functional group. This is said to be it's a polarization or displacement. That is purely because of electron releasing nature or else electron withdrawing nature of the functional group. The phenomenon exactly mapping with the how we are pulling this thread. Okay, so here everybody aware about the game what we are doing here. So the people who are having high strength will get their side. Okay, so in the same manner, whenever electron withdrawing nature is there, that side this electron density displacement is possible, which is said to be an inductive effect. Inductive effect is purely resembled with this kind of game, right? So for your simplification, I mentioned over here. Let's see how can we see the inductive effect. So there is a example provided, and inductive effect is shown between the carbon atom and the given functional group. Certain functional group, I'm going to mention about OH hydroxy, being it is electron releasing in nature, so that arrow is mentioned towards the carbon because it is releasing electrons like this, so that it is not completely releasing, rather a partial displacement of electrons towards the carbon atom will be there, so that you can notice a partial positive charge. Partial positive is mentioned with the dou, plus. Dou plus indicates what? Partial positive, right? It is a slight displacement, slight dislocation of the bonded electrons towards the carbon atom. Okay, so we have to see the head of the arrow. The arrow head indicated towards the carbon. That's the reason why it mentions what? Electrons released from the functional group. So that carbon is gaining electron density. Electron rich nature can be mentioned with the negative sign. So that let me mention partial negative. And not only the first carbon, even second carbon experience the same electron density, but certainly less effective. So that I mentioned two dose signs. That means a somewhat weak effect will be there. The electron releasing nature experienced by the first carbon, and even second carbon experiencing the electron rich nature by do negative charge, and even third carbon experiencing do negative charge. This is the way electron releasing nature can be indicated through the arrows. And this dou positive, dou negative indicates the partial charges which are generated due to this electron releasing nature, right? And what this OH is saying, I'm electron releasing group. So this OH is releasing to the carbon, so that this is said to be electron releasing. And electron releasing group can be simply indicated with ERG or else EDG. ERG stands for electron releasing group, electron donating group. Okay, both are same only. Then move on to any other condition where chloro is having a high electron negativity and having strong electron pulling nature. Strong electron pulling nature will be there. That's the reason why carbon is releasing electrons towards the chloro. So the chloro is acquiring electron density, which is mentioned with the partial negative charge. Though because of this reason, carbon is getting partial positive because electron density is somewhat displaced towards the chloro, so that it is losing, hence partial positive. And the next carbon also experiencing but less extent. So double dou is mentioned over, and next carbon also experiencing, where this is saying I'm electron withdrawing. Electron withdrawing group is simply indicated with EWG, right? This is the way inductive effect is mentioned within the compound. Okay, either electron releasing may be present, electron withdrawing also present. Electron releasing can generate the negative charge on the carbon skeleton, and electron withdrawing can originate partial positive charge on the carbon chain, right? So this is about inductive. Then how can we measure and what types we have? Inductive effect can be categorized into two types. One is said to be plus I effect, which is also called as a positive inductive effect, and minus I effect is called a negative inductive effect, right? Just now we saw both the possibilities, how it is releasing, how it is accepting both, right? So positive inductive effect is defined as the tendency to release the electrons into the carbon chain and increase the electron density in the chain is a positive inductive effect. Any functional group having natural tendency to release the electrons from that functional group to carbon skeleton, then it is said to be what? Positive inductive effect. Itself it is gaining positive charge. You can notice positive charge in that functional group, right? So minus I effect is nothing but the tendency to absorb the electrons from the carbon skeleton and decrease the electron density in the chain, which is called a negative inductive effect. Itself it is acquiring the negative charge and it is gaining the electron density from the carbon skeleton, which is called minus I effect. Plus I effect called releasing of electrons. Minus I effect is called accepting of electrons from the carbon skeleton, right? Now let's see the individual examples related with positive and negative inductive effect. Plus I effect purely because of electron releasing group, so that we can go with methoxy, tertiary methyl carbon, secondary methyl carbon, and 1 degree methyl, 1 degree ethyl carbon hydrogen will be there. This is the way methoxy, what we can say tertiary, and this is called what? Isopropyl, ethyl, methyl, and hydrogen. This is the way descending order for electron releasing nature. And minus I effect is provided with the relative comparison. Electron withdrawing nature decreases. What happens? Minus I effect also decreases. Let me mention NH3 positive, where electron density completely lost on the nitrogen and followed by NO2, nitro. CN, nitrile, SO3H, sulfonic acid, CHO, aldehyde, CO, ketone, COOH, carboxylic acid, COCl, what we can say, acid chloride, CONH2, amide, fluoro, chloro, bromo, iodo, hydroxy, alkoxy, amino, phenyl, hydrogen. This is the way comparison between the minus A effect is there for electron withdrawing groups, right? So this is about what examples. Now we are going to discuss about what conditions we have, what specifications we have for inductive effect. In order to explain about inductive effect, certain specifications or its conditions to be satisfied. Let's see what are the conditions. Is a permanent effect. Just now we said inductive effect is said to be a permanent effect, so always it existed in the molecule, which can't be diminished. So it is a permanent, and moreover electronic effect, purely because of electron displacement. That's why we can say it is an electronic effect, permanent electronic effect. Okay, inductive effect is called permanent electronic effect. Displacement of electron density towards electronegative group. This is most important to remember. Among two atoms, whichever having high electron negativity, towards the electronegativity, that displacement of bonded electrons are possible. That is a common criteria in case of this inductive effect. Electronegative atom, the bond displacement is possible, and whenever that bond is slightly displaced, so that we will experience partial charges, not complete. They are not completely, you are taking complete electrons, I am completely losing, not like that. Rather, partial charges generation is possible. This is the way a partial charge generation is represented with the dot sign, just now we saw. And purely it is related with what, sigma bonded electrons only. The bonds which are formed by the axial overlapping, and the lobes will be in a direct contact, then only sigma bond the electrons will be displaced. Rather, pi bonded electrons, lateral overlapping bonds will not be affected by this, right? So this is purely for sigma bonded electrons. Origination of permanent dipole, right? So here, being it is a permanent effect, we can say one of the atom, either carbon may get a positive charge and the functional group may get a negative charge, or else carbon may get a negative and the functional group may get positive charge. This is the way a dipole can be originated. Dipole means what? One of the atom is positive, another atom is negative, so that we can say dipole it will be. So always in case of inductive effect, that used to originate the permanent dipole, so two charges will be originated over there. And most importantly, up to the third carbon this will be applicable. So that kind of pulling of electron just now we mentioned over here, you can clearly notice here, whatever functional group releasing or else accepting, that is applicable up to third carbon atom. Beyond that, it will not be operated. Up to the third carbon, you can notice the inductive effect, right? So these are the important conditions required to be fulfilled in order to operate this inductive effect. Later on, I have another question. What is the consequence on the chemical reactivity? What inductive effect is due on the chemical reactivity of the substance? So in order to measure the acidic strength of the carboxylic acids are for sure they are acids only, but comparative acidic strength can be explained by using this inductive effect. Based on inductive effect only, which is stronger acid, which is weaker acid, can be given. Most expected question framing part is this strength comparison only. I'm going to compare the carboxylic acid strength. Here I have CH3COOH. Here HCOOH is there. Here we have fluoroacetic acid, difluoroacetic acid, trifluoroacetic acid. How can you say this is the order where the increasing acidic strength is gradually observed? Why this kind of order you are writing over here? This is purely explained by means of inductive effect. What inductive effect we have in this molecule? Plus a effect is there, because methyl always electron releasing due to the hyperconjugation effect, and electron releasing means plus a affecting group is there. Whenever electron releasing on this, so what is the acid? Any acid having natural tendency to release H plus. H plus releasing feasibility should be high, then only we can say it is stronger. But what it is doing, electron density is released into the carboxylic acid. Whenever electron density accepted, this oxygen is becoming electron rich. Whenever oxygen is becoming electron rich, it is not having tendency to pull the bonded electrons, because already it is having sufficient electron density, so that electrons are not strongly pulling. So H plus is not easily removed from this one, so that it is the least acidic compound. And move on to HCOH. Here Plessy effect is operated, but here Plessy effect, complete inductive effect is absent. Inductive effect is zero. So that naturally carboxylic acid is acid, no? So that it will show the acidic strength. So compared to acetic acid, formic acid is a stronger acid, right? Move on to fluoroacetic acid. Fluoroacetic acid if taken, what fluoro will do? Fluoro having natural tendency to drag the electrons backside. It is pulling electrons. Whenever electrons are dragging towards the fluorine from the carbon skeleton, oxygen is obviously becoming electron deficient. Deficient oxygen having strong tendency to displace the bonded electrons, so that H plus easily removed. Whenever H plus removed, it is becoming stronger acid. Okay, so compared to one fluorine, two fluorines having more strength to pull the electrons, so that more the strength of acid. And three fluorines will decrease the electron density completely on the oxygen, so that hydrogen easily removed, so that it is becoming high acidic compound. This is the way acetic acid is least acid, formic acid is the next level, and fluoroacetic acid, difluoroacetic acid, trifluoroacetic acid. This is the way we can go for the increasing order of the acidic strength. Move on to another. I'm going to compare with the electron releasing and normal one, electron withdrawing, and moreover in the electron withdrawing, I'm going to compare the para, meta, and ortho substitution. What it will show the effect. So whenever electron releasing groups are present on benzoic acid, again benzoic acid is the acid, no? So that here acidic strength is dependent upon the inductive effect of the substituent. So here substituent is the methyl. What methyl will do? It will show the Plessy effect. Always Plessy effect will decrease the acidic strength, so that we can say orthomethyl benzoic acid is least acidic, so that it is a least acidic compound mentioned at least. And next is about benzoic acid. Inductive effect is absent, we can say. Substituent wise, inductive effect is absent, but phenyl group obviously having electron pulling nature from this one. Compared to this one here, electron releasing strength is not there. And next is about nitro group. Obviously, nitro is minus I affecting group, having natural tendency to pull the electrons back. Whenever pulling electrons back, para position is far distant, so that pulling nature is somewhat comparatively less. And next followed by meta position somewhat near, and it shows the electron pulling nature next level. And extremely larger extent of electron pulling nature is there in the orthonitro compound, so that this is the way we can go for the comparative study about the acidic strength of carboxylic acid. This purely relies on the inductive effect. Either it may be plus I effect, minus I effect, what kind it may be, but all kind of acids are compared with their inductive effect only, right? So this is the way acidic strength can be explained for the carboxylic acids. Okay, so by this consequence in the chemical reactivity mentioned, move on to next question. Is there any significance for this kind of inductive effect? Why we need to study about this type of topic? Absolutely, we have high significance for this one. Most application oriented concept it is. So acidic and basic strength determined and compared. So whether it is acid or base can be determined, and moreover we will go for comparison of its strength. Okay, so here acidic strength just now we gone through with the carboxylic acid, already it is mentioned and repeated once again. And you can go for basic strength as well, right? First of all, we will see this is called orthotolic acid, benzoic acid, and paratolic acid. Orthotolic acid is having higher carboxylic, higher what acidic strength we have. Benzoic acid is the next level, and paramethyl benzoic acid is having least extent of acidic strength. This explained based on the Plessy affecting group. So there is no Plessy affecting group. Here ortho position is having Plessy effect. Here para position is having Plessy affecting group. This is the way acidic strength is compared. Ortho is having higher, and next is about no methyl, and next is about paramethyl. And move on to this aniline. In this aniline, NH2 is called what? Basic in nature, because the nitrogen always resided with the lone pair of electrons and natural provision to release the electrons, so that it is basic in nature. So this is said to be purely aniline without any substance on the benzene ring. Now let me put on nitro over there. Nitro is the electron withdrawing, right? Withdrawing means what it will do? It will drag the electron density. So nitro is dragging electron density, so that nitrogen, this amino nitrogen, is not free to release the electrons out. Whenever nitro is not enough density on this, and the electrons are not free for the donation, its basic strength somewhat reduced. And compared to meta, para is having still higher tendency to drag the electrons very strongly. So it can be explained based on their quantification is also provided for your authentic reference. Okay, para is having higher strength to pull the electrons inward. That's the reason why basic strength still decreased. If you go for ortho, this nitro is still near to the NH2, so that the tendency to drag the electrons with the high power. That's why least the basic nature will be. Anyway, electron withdrawing groups when present, what happens? Basic strength decreases. That's why in comparison to aniline, wherever nitro, all are least basic only. But among all, orthonitro is the least basic, paranitro is the next level, and metanitro is the next level basic, and highest basic will be the aniline. Then how can we improve the basic nature of this one? By introducing any electron releasing groups. If you introduce any methyl group over there, or else methoxy group, so that aniline is becoming more basic. This is based on what? Plus I effect. NO2 is having minus I effect. Electron pulling nature is there. That's why they are withdrawing the electron density from the system, so that electrons not free for the release. Whenever electrons release, then only we can say it is base. Electrons are not free for the release, right? That's why the basic strength decreases in the presence of NO2, right? So this is the way basic strength, acidic strength compared. Move on to second application, significant factor, stability order of carbocations and carbon ions. Again, here inductive effect plays a role to mention the stability of carbocation. Carbocation denotes any carbon resided with the positive charge upon. Positive charge containing means electron deficient. Being it is electron deficient, how it will be satisfied? Any electron releasing groups are there, then only it will be satisfied, then only it will become more stable, right? So if you go with methyl, what carbocation is having 3 hydrogens. Hydrogens are not having sufficient electron density to release. That's the reason why here least stable. And next is about 1 degree. In that, one alkyl is there. Alkyl always having tendency to release the electrons, right? So that alkyl is releasing electrons to the carbon. So this is called 1 degree. And where one of the alkyl is giving, so that its stability somewhat increased, its hungerness somewhat compensated. And in case of next level, 2 degree, where two alkyl are giving electrons to the carbon. 2 alkyl are giving, what happens? Carbon electron deficiency somewhat reduced. Both are helping, right? So 2 alkyl are helping, so that its hungerness somewhat higher extent is satisfied, so that it will be more stable. But in case of tertiary, what happens? 3 alkyl having tendency to release the electron deficient carbon atom, so that it is becoming more stable. So it will be more stable. 3 degree carbocation will be more stable in comparison to 2 degree, in comparison to 1 degree, in comparison to methyl. This is the way stability of carbocation explained. Move on to carbene. reverse direction will be followed. What reverse direction? Alkyl is plus I affecting so that it will release the electrons, but carbon is already having negative charge. That means high electron density. What it requires? Electron releasing is required, electron withdrawing is required. Electron releasing is not favorable because already it is having rich electron density, so that methyl carbocation is more stable. Later on, 1 alkyl releasing is stable. Later on, 2-degree carbon is stable. Later on, 3-degree will be stable because around the carbon high electron density already there. Still electrons are released. What happens? They will do the repulsions, so that methyl carbon is a highly stable in comparison to 1-degree, in comparison to 2-degree, in comparison to 3-degree. This is the way inductive effect plays a role to mention the stability of carbocation and the carbon ion as well. Right. Move on to another application, stability order of free radicals. What exactly we played for carbocation, same can be applicable for free radicals as well, need not to mention. So whatever order followed in a carbocation, same is applicable to carbon free radicals, right? Move on to fourth application called relative reactivity of carbonyl compounds. Carbonyl compounds are nothing but any compound is containing C double bond O. C double bond O group if present, that is called a, there is a way to mention the reactivity order of carbonyl compounds where C double bond O is designated as a carbonyl, and we have 3 different carbonyl compounds said to be formaldehyde, acetaldehyde, acetone. And these are reactive towards nucleophilic addition. Nucleophilic addition stands for, so wherever carbonylic carbon is there, this is more susceptible to react with any negatively charged species, which is called a nucleophile. And moreover, always the double bond is reactive towards the addition reaction, so that we are saying nucleophilic addition. Then how can we compare like this? Why formaldehyde is more reactive in comparison to acetaldehyde in comparison to acetone? Again, inductive effect plays a vital role over here. How? Here, whenever 2 hydrogens are surrounding this carbonyl, carbon is not having any tendency to gain the electrons now, so that it is having sufficient electron deficiency. Deficiency present, electron rich nucleophile will come and react over there, so that high reactivity can be accorded. Move on to this one, methyl. What methyl will do? Plus I or minus I? Methyl having plus I effect. Whenever methyl is having plus I effect, so carbon is becoming electron rich, so that any nucleophile is coming difficult to react. And moreover, it also shows another effect called steric hindrance. Nucleophile is not suitable, not easy to react. But here we have 2 hydrogens only smaller. But here methyl is bulky. Bulkiness is one reason. Inductive effect is the second reason to restrict the nucleophile to go for nucleophilic addition. And move on to this acetone, where we have 2-methyl having more tendency to release the electrons, higher the electron releasing nature, so that electron density and the carbon got highly increased. Nucleophilic addition becomes difficult. That's the reason why least reactive, next level acetaldehyde, and the highest will be formaldehyde. This is purely based on inductive effect of methyl. And by this, we covered with the entire concept of inductive effect. Let's see with the question pattern based on this inductive effect. What previous questions we got over there? So the question regarding the electronegativity. Electronegativity and inductive effect are directly related. So among the carbon and functional group, whichever atom is having higher electronegativity, that side electron displacement is possible. That's the reason why before knowing about the inductive effect, it is obvious to know about electronegativity. Electronegativity means what? How can we define this electronegativity? Electronegativity defined as the power of atom in the molecule to repel the electrons, attract the electrons, expand itself, all of the mentioned one. Okay, always electronegativity having natural tendency to pull the electrons towards the atom. So it will attract the electrons towards, so that electronegativity is the natural tendency to gain the electrons. Among the entire elements of the periodic table, fluorine is the most electronegative, francium is the most electropositive element. And effect of electronegativity clearly mentioned among sodium chloride. Sodium is highly electropositive, chlorine is highly electronegative. There is a fight in between. So both are fighting for electrons. So obviously chlorine of high strength of electronegativity, so that it will gain the electrons like this, so that sodium is becoming electropositive, and chlorine by gaining electrons becoming electronegative. This is the way electronegativity can be explained. The power to gain the electrons is called electronegativity. Move on to another question. How does the electronegativity get affected by negative oxidation state? Already any atom or the molecule is having a negative charge upon. Then how this electronegativity will show the effect? So whether electronegativity increases or decreases or remains constant, and we can't answer this. So which is your answer? So already any species is having negative charge upon, so that electronegativity will not be operated, because so whenever negative charge is there, and again we are pulling electrons, what happens? Repulsion between the electrons are possible, so that what happens? The effect is decreased. Electronegativity effect is decreased, because always any species having negative charge, high electron density, again pulling electrons, a high electron density. So gained electrons, existing electrons will fight each other. That's the reason why repulsion plays a vital role over there. So electronegativity effect will be decreased in case of that species. Okay, that is purely because of repulsions, right? So if you see this water molecule, oxygen having partial negative charge, hydrogens are acquiring partial positive charge. This is the kind of permanent dipole displacement in water molecule. And move on to another question. The electronegativity of sp2 hybridized atom will be, okay. So the based on this s orbital contribution, its electronegativity depends. What relation we have? Higher the s character, greater will be the electronegativity. S character, electronegativity both are directly proportional to each other. As the s character increases, electronegativity value also increases. Okay, so in case of sp2 hybridization, electronegativity of the carbon will be 2.75. So it is contributing 2.75. If you go for triple bonded carbon, so triple bonded carbon is having sp hybridization. Sp means 50% s orbital contribution, 50% p orbital contribution, so that s character is higher. Whenever s character is higher, this will be more electronegative. And whenever double bond is there, sp2 hybridization, that means a 75% p character, 25% s character will be there. So here 50%, here somewhat decreased. Here sp3, so sp3 75 and 25. Here we have 66 and 33. So in case of double bond, 66 and 33 percentage s character and p character will be there. Two p orbitals and one s orbital rate. That's the reason why 66 percentage of what p character will be there, and 33% s character will be there. In case of this single bonded carbon atom, only 25% s character and 75% p character will be there. So this is the way we can go for percentage of s character, and consequently percentage of electronegativity will be there. That is purely explained with their acidic strength. pKa value is lower, acidic strength will be higher. Always pKa value is the symbol, or it is the indication for acidic strength. So there is a relation like this: pKa value inversely proportional to acidic strength. If you see pKa value 25, this indicates higher the acidic strength for this triple bonded carbon atom. And for this double bonded one, pKa value is 42, comparatively high rate, so that acidic strength is least. And when you go for carbon-carbon single bonded CH, where pKa value is 50, when compared to this one, it is still high, so that we can say acidic strength is still less. This is the way there is a relation like this. How can we explain the relation? Hybridization and electronegativity are related. And based on electronegativity, their acidic strength is related. In this manner, we can go for a series of reactivity order. So if you know these fundamentals, how many questions we have, all are very easy for answering, right? So if we are having S character higher, obviously electronegativity value will be higher. Okay, greater the S character, greater will be the electronegativity. Then electronegativity is higher, what happens? The acidic strength of that hydrocarbon is also higher. This is the way we can answer this one. sp2 hybridized carbon, the electronegativity will be 2.75. And another question, which of the following is called a permanent electron displacement? Within the definition itself, we mentioned inductive effect is the permanent effect, and electron delocalization or else electron displacement is possible. That is called inductive effect, right? So that is called inductive effect. Option number C is the correct answer. Arrange the following groups in the order of decreasing Plessy effect. Plessy means what? Electron releasing nature. Electron releasing electron functional group is called Plessy affecting one. So among all, the highest electron releasing nature is given for phenoxy. And next is about carboxylate. Next is about CR3, trialkyl carbon and dialkyl carbon, and hydrogen is least. Highest is given for phenoxide because negative charge is there, and this negative charge is delocalized with the benzene ring. So that highest Plessy affecting nature is accorded for this alkoxide. Any alkoxide is of electron releasing, Plessy affecting only. Right. Move on to another question. Seventh question. Arrange the following groups in the order of decreasing minus A effect. Plessy effect completed. We are moving to minus A effect. Minus A means electron withdrawing nature, withdrawing strength. In order to explain about electron withdrawing nature, we have nitrile first. Highest pulling nature is given for CN, nitrile, followed by carboxylic acid, and next level fluoro, chloro, bromo, iodo, and least for hydrogen. Nitrile is having highest electron withdrawing nature over there, right? Which of the following is an application of inductive effect? Inductive effect is used in the measuring bond length. How can you measure the bond length with the help of inductive effect? So if inductive effect is not there, bond length is as usual what practically expected, that remains the same. Whenever inductive effect is operated, bond elongation is possible, right? So and bond displacement is possible, so that bond length is affected by inductive effect. Dipole moment, okay. So dipole moment, in the sense, it is the kind of charge separation, how extent charge separation is there among the atoms, which is explained by dipole moment. It is measured in debye units. The dipole moment purely depends upon inductive effect and consequently electronegativity. So the dipole moment, there is a direct relation. Strength of the carboxylic acid, just now we clearly explained about strength of the carboxylic acid by means of inductive Plessy effect groups present, carboxylic acid strength decreases. Minus A affecting groups present, carboxylic acid strength increases. This is the way everything got explained, so that A is correct, B is correct, C is correct. All mentioned is the correct answer. Bond length affected, dipole moment affected, strength carboxylic acids, replications of inductive effect. Okay, move on to question number 9. Relative basic strength of amines does not depends upon. So here already we explained about amines. So we gone through the aniline. Strength of aniline is explained. Whenever nitro is present at ortho position, meta position, para position, how the acid, basic strength is influenced, we clearly mentioned. So that inductive effect directly related with the basic strength. So it is related only. Mesomeric effect will not be related with that one. Steric effect. So whenever tertiary, we can clearly explain about 1 degree amines, 2 degree amines, 3 degree amines. Actually, whenever electron releasing groups increases, what happens? Amine basic strength should increased, but the 3 degree is not having that enough basic strength in comparison to the 2 degree. That is purely because of 3 bulky alkyl group can hinder the electrons to travel outside. They occupying the entire sphere around that amine, so that electrons not free for release. Though electron rich nature is there, but steric hindrance also matters for the basic strength. Tertiary amines are not enough basic in comparison to the secondary. That is purely because of their steric hindrance. Steric effect also matters. Stabilization of cation by the hybridization, right? So here, whenever cation is formed, so for example, base means what? Base nature of base can be explained by different definitions. Either electron releasing tendency is called base, or else acceptance of H plus is also called as base. Okay, whenever amine is NH2 is accepting H plus, what happens? By gaining H plus, that NH2 is turned into a positively charged cation. Ammonium cation will be formed. Whenever that cation is formed, so whenever that cation formed, that should become stable upon hydration. Whenever it is added to water, that stability should be more. Then only that is susceptible to become a base and to accept the H plus. So this also matters for what amine to decide its basic strength. But mesomeric effect is not having. Mesomeric effect not having any effect on its basic strength. Relative basic strength of amine does not depends upon mesomeric effect. This effect is used in the qualitative way and describes the electron withdrawing and releasing properties of the substance. Mesomeric effect, electron, how extent electron released and withdrawn, that only explained by this one, so that it is not the relevant property to explain the basic strength, right? Move on to question number 10. Due to the presence of carbon halogen polar bond, alkyl halide, in alkyl halides are, so uh, CX bond is more polar. That polarity is because of what? Inductive effect only. This matters for inductive effect. So because of this inductive effect, this bond is not exactly laying between the carbon and halogen, rather slightly moved towards this halogen, and we will attain the carbon as a partial positive, halogen as the partial negative. So because of this partial dipole generation, partial permanent dipole generation, alkyl halides are more reactive in comparison to the alkanes. Alkanes are having carbon hydrogen bond only. Carbon electronegativity, hydrogen electronegativity, both are comparable. Both are almost comparable. So that nobody are taking electrons towards that one. The electrons exactly laying in between, so that per proper sharing of electrons are possible in case of alkanes, so that polarity is absent and reactivity is absent. But in case of CX bond, there is a high polarity and dipole generation is possible because of inductive effect. Because of inductive effect, they are more reactive in comparison to the alkanes. So that A is the correct answer, right? CX bond is polar in alkyl halide, so that they are more reactive in comparison to the alkanes. Alkanes, carbon electronegativity, hydrogen electronegativity, both are almost comparable, so that no bond displacement. Inductive effect plays a negligible role over there. And this is another question collected from JE Advanced, expected question 2024. Strength of aliphatic carboxylic acid and benzoic acid. Okay, carboxylic acid and benzoic acid. So we are going to compare. For example, I'm taking CH3COOH and C6H5COH. That means one is acetic acid, second is benzoic acid. What is the strength of aliphatic and aromatic? How can we compare? Always this alkyl is plus A affecting group. So alkyl is having natural tendency to release the electrons, so that acidic strength decreased. So plus I effect, acidic strength will be lowered. But in case of phenyl, benzene ring, what happens? Benzene having natural tendency to pull the electrons back. Whenever electrons are pulled towards benzene ring, carboxylic acid is becoming more acidic, so that benzoic acid will be more acidic in comparison to the acetic acid. This is purely because of what? Inductive effect. Plus a effect operated in aliphatic, minus a effect operated in aromatic. This is the way strength of acids explained. And in either comparison, I'm going to compare with the formic acid, benzoic acid, and this is said to be a aliphatic carboxylic acid. Highest acidic strength, where you can find highest acidic strength. Benzoic acid is stronger acid than aliphatic carboxylic acid, but exception is formic acid. Formic acid is having highest acidic strength. What could be the reason behind that? Formic acid, there is hydrogen. This hydrogen having natural tendency, inductive effect is negligible, neither release nor accept the electrons. That's the reason why this carboxylic acid having natural tendency of oxygen to pull the electrons, no inductive effect is operated over this oxygen natural tendency of its electronegativity, so that hydrogen will be easily released. In case of benzene, there is a partial double bonded character originated between the benzene ring and the carbon, so that particularly inductive effect operated, and this acidic strength is somewhat decreased in comparison to the formic acid. And in case of methyl or any alkyl, what happens? This is showing Plessy effect. The Plessy effect generally decrease the acidic strength. So this is the way formic acid will be the highest exceptionally, benzoic acid next level, and aliphatic carboxylic acid is the least acidic because of Plessy effect. This is also acidic strength based question. And here another peculiar question you can go for. NO2 is there, nitro, and here fluoro is mentioned, and chloro is there, and bromo is there. So this is the question can be answered if you know the entire series of this strength of inductive effect, negative effect strength comparison we shown. In that, NO2 is having highest minus a affecting nature in comparison to fluoro, and next level chloro, next level bromo will be. So this is the way nitro, if present on carboxylic acid, this will become more acidic. Later on fluoroacetic acid, chloro and bromoacetic acid. If you compare the trifluoro, trichloro, tribromo, triiodo, obviously chloro is of higher electronegativity, so that acidic strength will be higher in comparison to chloro, bromo and iodo. And next, I'm going to explain about the new concept called hydroxy compounds. Whenever hydroxy compound taken into the picture, their acidic strength we are going to compare. Acidic strength means H plus releasing tendency. One methyl, what happens? Plessy effect is least, so that more acidic. Here we have CH3, CH2, so that electron releasing nature somewhat increased, so that acidic strength decreased. Dialkyl, more Plessy effect, so that acidic strength still less, and trialkyl 3 inductive effect place, so that acidic strength still lower. So here, as inductive Plessy effect decreases, as Plessy effect increases, acidic strength decreases. Plessy effect inversely proportional to acidic strength. This is the point you have to notice from the entire slide. Only one point we are going to explain by these many examples. Greater the plus I effect, lesser the acidic strength. Greater the minus I effect, greater the acidic strength. That is only the relation between the acidic strength and inductive effect. Move on to another question, expected question for the MCET examination. And again, it is the acidic strength only. These are the benzoic acid derivatives. All are benzoic acid compounds only. One of the compound is having 2 hydroxy, in either having only 1 hydroxy at ortho, at meta, at para position. Among all, where you can find more more acidic strength. What actually OH? OH plays a Plessy affecting nature. Whenever Plessy affecting nature is present, acidic strength gradually decreases. More Plessy affecting groups, less will be the acidic strength. So that obviously option 1 is the least acidic compound. And the next very near OH is the next level least compound. And meta is the next level least compound. Para is the highest acidic compound. So that we can go for the order 1 is least, 2 is next level, 3 is next level, highest is recorded for the para-hydroxybenzoic acid. This is a comparison, and again purely relies on what? Inductive effect, and the placebo effect is operated over. So by this, we entirely completed the detailed description for the inductive effect. So exclusive concept was taken, inductive effect, and we gone through the what is that inductive effect, how can we categorize, what examples we have, what applications we can avail by this, and what are the previous year question papers from the various authentic platforms. I hope the session is very informative and you will get the comprehensive data regarding the inductive effect. And like the channel, this is a sincere request, and comment what questions you solved based on this inductive effect. So you can comment, so questions what you're going to solve, or else what questions you solved based on this inductive effect, those questions, and or else what practice questions you made, that can be answered in the comment section, and share with the aspirants who are serious for the examinations, and subscribe the channel to receive more updates in the near future. We will go for new content in new ways, and new aspirations will be developed based on this. Thank you very much for your patient listening.